space-time on the curve. This is basically what it's all about. Yeah.
Seems to be an easy one. We have completed our SAT Physics Waves and Optics videos on YouTube. So feel free to check those out. I think I can attach a link to that at the end of the meeting. We'll be keeping that posted in various places. So those are completed. All right. According to general relativity, gravity is not a force. As Wang was explaining earlier, gravity is actually the curvature of space-time. And that tells us that, like, if a person is falling from a roof at 9.8 meters per second squared, it's kind of the same as someone just in a spaceship coasting along at constant velocity, because they're both under the influence of the curvature of space-time, according to general relativity. All right, this one is true. Light is bent around massive objects, such very big objects, right? Like a neutron star, for example, light can be bent around that, or like in black holes, like a black hole can suck in the light. So light can be bent around massive objects according to the curvature of space-time. So this is true. So this is a quote from John Archibald Wheeler. I switched the words curve and move here. So the quote is space-time tells matter how to move, matter tells space-time how to curve. This is a trippy question, and the answer to this one is false. That is John Archibald Wheeler. That was a photo of him.
Okay, the answer to this question is all options, because the theory of general relativity requires differential geometry study, and differential geometry requires tensor analysis, linear algebra, as well as some multivariable calculus to study. And differential geometry is one branch of mathematics that studies geometry using essentially calculus. For example, if you can easily deal with the geometry in a flat space, but if like on a sphere, you can also do it by parameterizing the sphere. But like if the space where like the curvature is changing over at different locations, you have to use some like calculus to do it. This is the field of different geometry essentially, and it can be really complicated.
Yes, so all of these actually apply, and they're all correct answers. Now we're getting into the news ones. Some of the news we've been covering over the past few weeks. So we showed this one a few times. This one is a black hole. Penumbra was one of the other news ones that Alan was actually presenting about like last week. So here in this image, you might notice that this the area of light at the bottom is a bit bigger than the one at the top. And that's because the black hole is actually spinning. It has an angular momentum here. And that causes that shows more light at the bottom as opposed to the top right here because of the spinning black hole. Right, everyone got this one. This one was one that Bohong was showing, that black holes can coalesce. He was showing one of the videos from his presentation showing how two black holes can merge together in accordance with like the rules of general relativity, that two black holes can merge together. This one shows gravitational redshift. And gravitational redshift is where light shifts to slightly longer, redder wavelengths according to general relativity. And this was part of the news. It was measured. I think Northwestern University had like an article about this. And this is the spectrum of iron, I think you can see right here. You can see that there's a graph of X-ray brightness and wavelength. All right, so we talked about the 2020 Nobel Physics Prize a few times in the club. It was won by Doctors Penrose, Genzel, and Ghez, and it was about black holes. Penrose did a lot of the calculations regarding black holes, showing it to be like part of general relativity. Doctors Genzel and Ghez did a lot of astrophysics and saw that indeed in the center of the universe we do have a black hole. And you can kind of see that written over here. So a very important application of general relativity was the 2020 Nobel Physics Prize. These last two are just reflection questions, they're 0 points. All right, for this question, it's also 0 points. If you have a recommendation, you can check that option and put recommendations, but we're always looking to improve the club. All right. Seems that everyone liked the Kahoot. All right, those are all the questions that I had for this Kahoot. Congratulations, everyone. Nice work with the Kahoot.
Right. So yeah, that's really great. And we have some announcement coming up. So next week is Thanksgiving, and wishing everyone a happy holiday first. But after Thanksgiving, Andrew Huang, if you guys know him, he agrees to be our guest speaker and come back the first week after Thanksgiving to give a guest lecture on he's studying as a freshman at UC Berkeley, and he's doing some research in physics, and he will also talk about some of his experiences so far at Berkeley, although it's virtual. Yeah, so we'll be putting out a survey later, and if you guys are interested, please submit it. We are very excited for that. And let me find the survey. And at this time, if you have any questions or anything at all, just feel free to unmute and put in the chat. So the survey is in the chat, and Andrew is available on these time slots in the afternoon, only from Monday from Wednesday. So please fill that and we can better coordinate time. And Mr. Alman, are those time okay with you? And you can also like.
Yeah, I'm here.
So will you be free from after school to like 4:30 or 5? I mean, Andrew.
Yeah, I can. I should be able to do any of those. Be great to have him back.
Yeah. Nice. So if you're done with the survey, it's a short day, and yeah, and feel free to hang out or leave, and yeah, great day.
Hey, Rohan, I just sent you an email asking for the link for the SAT videos. I'd like to post those on my Moodle page and announce it to the classes.
I will give you the link. I think I had it in one of the previous presentations, so I'll send that one over.
Awesome.
All right, that's some results.